Hello everyone, my name is Mrs. Taton Chloe. Today we are going to talk about converting numbers from decimal to binary system. As you can just remember, in first year we introduced you to how we measure the computer's memory. And as you have realized in the quiz that you have just responded to, I just tried to remind you of the units that we use when measuring the computer's memory. And if you can just go back and remember, we said that the computer's memory is measured in powers of 2. Why? Because the computer uses only 2 digits, 0 or 1. And then you can also remember that we said there is just no way you can have the computer's memory be measured unless it is a power of 2. That's why you'll never have a 3 gigabyte flash. You'll always have a 1 gigabyte, 2, 4, 8, 16, all the way. Those are the powers of 2, as you can just recognize the pattern out of that. And now we are trying to look at the connection between the decimal numbers and the binary numbers, because as you have seen, if you didn't, please go and check in your course outline. There's a topic that we are going to talk about which is called logic gates, and as we move on we'll also talk about the IP addresses. And then in order for you to be able to understand those two topics among the many that you'll be introduced to, you have to be able to convert the numbers from decimal to binary. And as you can see on the screen, the decimal number system has only 10 numbers. That's why I've written base 10 there, because it is normally called base 10. It has only 10 digits, 0, 1, all the way up to 9. And the idea is they took advantage that we have got at least 10 fingers, so we'll be able to use them when counting. But when it comes to the binary number system, it only uses 2 numbers or 2 digits, 0 or 1. There's nothing called a 2 or a 3, but there's a representation for that. Then we'll see how that comes. Then it is called base 2. Now when it comes to the way we write these numbers to differentiate them, now that you are aware that we have different number systems, we don't only have decimal and binary, we also have other numbering systems, but we'll come to them later on as we move on with the course. In order for you to differentiate between the two numbering systems, like I've shown you on the board, we have 0 with an index of 10, simply showing that it is a 0 in the decimal number system, but it is equal to the 0 that we have in the binary number system. So in order for you to show that this is a 0 in base 2, you have got to write the small 2 down there, which is called the index, the subscript. And the 1 in decimal 10, as you can see, is also equal to 1 in base 2. So from now onwards we have got to differentiate the 2, because when you talk of 10 in base 10, you can't say that is 10 as well in base 2, because 1 0 in base 2 means something else. It is not 10 as it would be in decimal number system. So be very careful that these numbers should be indexed. Now look at here, we have 2 in base 10. How much will that be in base 2? We have got to think about that, because we are saying in binary number systems we have only 2 digits, 0 and 1. We don't have something called a 2. Now let us move on to the other side of the board. As you can see, we are having these numbers. Don't go too far. We have 0 up to 9. These are the 10 numbers that we have in our system. From 0 to 9, these are the 10 numbers. Then when we move on, no new number is being introduced. In order for you to say 10, that's because you have used a 1 and a 0, which are already there in the system. And when it comes to 11, it is simply 1 and 1. And when it comes to 12, it's 1 and a 2, which are already there in the system. So what you have to realize here is that the 10 numbers that we have, 0 up to 9, are repeated, but 1 is kept constant for all of them. And by default, as you can see, on the first iteration, 0 is there by default. We know that mathematically, if you didn't show that there is a 0 in front, no problem with that. So the 10 numbers that we have, 0 to 9, for the first iteration, 0 is kept constant, just that you don't normally write it. For the second iteration, we have 0 to 9, but 1 was kept constant. When it comes to the third iteration, we have 0 up to 9, and 2 is kept constant. That means for the first iteration, we kept 0 constant, and then for the second iteration, we kept 1 constant. That's when you'll start to have 10 all the way up to 19. And for the third iteration, that's where we keep 2 constant. That's where we have 20 all the way up to 29. For the fourth iteration, then, keeping the numbers constant, 0 to 9. Then, in fact, repeating the numbers 0 to 9, 3 was kept constant. That's where you have 30 all the way up to 39. So you keep on doing that until we come to 99. 99 is what? 99 is simply 9 twice. What happened? We had the numbers 0 up to 9, and then 9 was kept constant. Then what happens? Since 9 was kept constant, now we have to keep 10 constant. And when we keep 10 constant, as you can see just here, when we keep 10 constant, and then we repeat the numbers that we have in the system, we have 0 up to 9, and 10 was kept constant. That's when you'll have 100. It was called 100. These are just the arbitrary units. You have 100, 101, 102, like that. So since this is the numbering system that we use, it is not normally written with the index, but to differentiate between the numbering systems, then you'll have to write the index. And then, as you can see here, when it comes to 110, 110 is nothing but 11 kept constant, and then writing a 0. When you write the 1, keeping 11 constant, that's when you'll have 111 until you have 119, which is simply 11 and a 9. So what will happen? For you to have 120, since you have exhausted the number of times you can keep 11 constant, then you'll keep 12 constant, and then start writing the first number, which is 0, all the way until you keep 12 constant, and then write a 9. So now, let's come to this side. The way we are doing it now is such that we are converting these numbers, the decimal numbers, to the binary numbers using the manual method, which is what I call the manual method, because it's simply about using the iterations. So remember, we said it's a 0 in base 10, 1 in base 10, 2 in base 10, 3 in base 10, 4 base 10, 5, 10, 6 in base 10, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, like that. So in order for you to write the binary equivalent of these numbers, we can simply write a 0 and a 1 because we know they are equal. But what happens when it comes to 2? We don't have a 2 that side. We have only 2 digits. So as you can realize here, for the first iteration, because there are only 2 numbers, we have a 0 there and a 0 here. By default, the first iteration, 0 is kept constant. Then what happens next? When we go to the second iteration, we will write our 0 and our 1 because they are the only 2 numbers we have in the system. Then keep 1 constant because 0 was kept constant previously. So what happens now? Now that we have kept 0 constant there, here 1 is kept constant, what happens? We now have to keep 1 0 constant. We will do that 2 times because we have only 2 numbers. Then we will write our 0 and our 1. Then what happens? Here we kept 1 0 constant. What's next? We had our 0 kept constant, our 1 0. Now we have to keep 1 1 constant. We do that 2 times because we have got 2 numbers, 0 and a 1. And then what's next? Now we have got to keep 1 0 0 constant. We will do that 2 times because we have got 2 numbers, 0 and a 1. And then what's next? 1 0 1. Another 1 0 1 because we have only 2 numbers. You cannot say this is 100 because it is not. It is 1 0 0. So what will happen is you'll write this as 0 base 2 1 base 2 1 0 base 2 because it is not a 10. This is 1 1 base 2. It's not 11, but as you can see, it is only equivalent to 3 in base 10. Now we have kept 101 constant here. Now we move on to 110. 110 constant, that will be 2 times 0 1. Now we move on to 111. It will be 111 111 0 and a 1. Now we move on to 1000. It is not 1,000, but it is 1000 0 10001. We are keeping this number here constant. And then we move on to 1001. It will be 1001 1001, and then write our 0 and our 1. Now we have come to 19, but assuming we had to know how much 50 will be, we wouldn't afford to do this all the way. So watch out for the next video whereby we will use other methods, the subtraction method and the division method, to get the numbers which are bigger than 20 because we have gone up to 19 here. So you will be able to convert quickly the decimal numbers to the binary numbers using those 2 other methods. This one is called the manual method. So remember, for example, here this is 111 in base 2. You have got to write the index for all of these numbers. Thank you very much for watching. Watch out for the next video.